In this video, we're talking about how to sketch a parametric curve, including how to indicate its orientation. And we're going to be doing a couple of examples. The first one is the parametric curve given by these equations. X equals 3 cosine of t, and y is equal to 3 sine of t. And we've been told that the parameter t is defined between 0 and pi. So how are we going to go about sketching a curve that's defined this way? Well, the first thing we want to do is what's called eliminating the parameter. In other words, we want to get rid of this value t, and instead of having two equations that define the curve in terms of t, we want to have one equation for y that defines the curve in terms of x. So here's how we can easily do that. We want to take the curve for x and we want to divide both sides by 3. So if we divide both sides of this first equation by 3, we're going to get cosine of t is equal to x over 3. And then remember that when we have a right triangle, so if we draw a right triangle that looks like this, what we know is that cosine of the angle t, if this is the angle t here, that cosine of the angle t is equal to the length of the adjacent side divided by the length of the hypotenuse. So if cosine is adjacent over hypotenuse and we have x over 3, then we can call x the adjacent side and 3 the hypotenuse. So we can go ahead and say x and 3. And then we can use the Pythagorean theorem to find the length of this third side. So we would go ahead and say x squared plus, we'll just pretend that this is b for now, so we'll say b squared is equal to 3 squared, or 9. Then we'll say b squared is equal to 9 minus x squared, and then b is equal to square root of 9 minus x squared, and we can go ahead and label the length of this side as root 9 minus x squared. Now that we have all three of those sides, we go back to our equation for y. We have y is equal to 3 sine of t. Well, we know that sine of the angle t is going to be opposite over hypotenuse. This is all coming from the trick SOHCAHTOA, where we know that sine is opposite over hypotenuse. So if sine is opposite over hypotenuse, this is the opposite side, this is the hypotenuse. So what we can say is y is equal to 3, and then replace sine of t with opposite, root 9 minus x squared, over hypotenuse, which is 3. Then we get the 3's in the numerator and denominator to cancel, and the equation becomes y equals root 9 minus x squared. Now we can simplify this equation by squaring both sides. That'll give us y squared is equal to 9 minus x squared. If we add x squared to both sides, we get x squared plus y squared is equal to 9. And that's definitely a simpler version of the same equation because this is the standard form for the equation of a circle with radius 3. So x squared plus y squared equals r squared, where r is the radius. That's the equation of a circle. So this is a circle with radius 3 that's centered at the origin. So now if we want to sketch the parametric curve, remember x squared plus y squared equals 9 is exactly the same curve as the curve given by x equals 3 cosine t and y equals 3 sine t. This equation and this equation are equivalent, they're just expressed in different ways. So if we now want to sketch this, we know it's a circle centered at the origin with radius 3, so we can go ahead and sketch the circle, and we'll say that it looks like this, and we'll say that this here is 3, and this is 3. But now, once we have this, our last step is to take into account the interval over which t is defined. So we've been told that t is defined between 0 and pi. Well, if we take t as the angle, we know that the angle 0 is given here along the positive direction of the x-axis, and the angle pi is a full 180 degrees this way, and this is the angle pi. Which means that if t is defined between 0 and pi, then our sketch does not actually include everything outside that interval, which is everything down here. So what we would want to do is get rid of that part of our graph, just leaving the top half of the semicircle. So now this is the curve, and we need to indicate orientation as our final step. And what that means is that we want to look again at the interval over which t is defined, and we want to take the smallest value for which t is defined. So that's 0. In other words, we're going to try to find the starting point for t. So if t starts at 0 and goes up to pi, we want to take 0, the starting point, and plug it into our two original equations for x and y. So if we plug 0 into each of these equations, what we're going to get here is x is equal to, cosine of 0 is 1, 1 times 3 is 3, so we get x equals 3. If we take 0 and plug it into the equation for y, we're going to get y is equal to, sine of 0 is 0, 0 times 3 is 0, so we get 0. If we put these two together, it's the point 3, 0, and that point is right here, 3, 0, which means that this is the starting point for the oriented arc or the oriented curve. So we're going to start here, and that means that we want to draw arrows moving away from here to the end of the curve, like this. So because 0 was the starting point for t, and plugging 0 into the original equation put us right here, that means that that's our starting point, and we're moving away from our starting point, so we draw arrows indicating that. Now let's look at a second example here. We have x equals 1/9 times 18 minus t squared, and y equals 1/3 t. One way that we can get these two equations in terms of just one equation defined for y in terms of x is we can solve this first equation here for x, we can solve it for t. So in order to do that, let's multiply both sides by 9. Doing that, we'll get rid of this 1/9, and we'll be left with 9x is equal to 18 minus t squared. Then we can add t squared to both sides and subtract 9x from both sides and get t squared is equal to 18 minus 9x. Then we can take the square root of both sides to get t is equal to square root 18 minus 9x. Now we can take this value we found for t and plug it into the equation for y. So since t is equal to root 18 minus 9x and y is equal to 1/3 t, we can say that y is equal to 1/3 times root 18 minus 9x. Now if we multiply both sides by 3, we get 3y equals root 18 minus 9x. If we square both sides to get rid of the square root, we get 9y squared is equal to 18 minus 9x. If we add 9x to both sides and subtract 9y squared from both sides, we get 9x is equal to 18 minus 9y squared. And then if we divide through by 9, we get x is equal to 2 minus y squared. Now this equation here, x equals 2 minus y squared, we can easily sketch. Remember that if we have y equals and then something in terms of x squared, it's going to be a parabola that opens up if x squared is positive and opens down if x squared is negative. Well, when we have x in terms of y squared, it's going to be a parabola that opens to the left if y squared is negative and opens to the right if y squared is positive. So we know that this is going to be a parabola that opens to the left. And if we just plot points, if we just plug in a few different points to this equation until we have enough points that we get a picture of what the graph looks like, what we can see is that, let's just put in a few hash marks here. What we can see is that we get the point here 1, -1, we get the point 1, +1, we get the point 2, 0, and the parabola ends up looking something like this. It comes in here, and then it comes around this way, like so. And so we have this parabola. This is x equals 2 minus y squared. But remember, just like with this example, now we have to take into account the interval over which t is defined. So we've been told here that t has to be greater than or equal to -3. So if we visualize that here, let's just draw in a simple number line. T can only be -3, -2, -1, 0, +1. So it's going to be everything this way, starting at -3. So let's try plugging in some points to see where t begins. So if we start at t equals -3 and we plug that into both of these equations here, plugging it into the equation for x, we're going to get -3 quantity squared. That's going to be a +9. 18 minus 9 is 9, and then 9 times 1/9 is 1. So we have here x equals 1. And then when we plug t equals -3 into the equation for y, we're going to get 1/3 times a -3. That's a -1. So that point, 1, -1, is this point right here. Now if we plug in -2, we're going to get -2 quantity squared is a +4. 18 minus 4 is 14. So we get 14 over 9, which is a little more than 1.5. And then if we plug it into the equation for y, we get negative 2/3, negative 2/3. So that's the x and y values at t equals negative 2. Well, if we find that point, t equals negative 2, 14/9 is right about here, and then negative 2/3, so we're something right about here. So what we can see is that we're starting here and we're headed in this direction. So what we can do is we can remove this part of the curve that is not included on that interval, but we can also sketch our direction moving away from the initial point and heading this way. This graph then, with the indicated orientation, is the graph of this parametric curve given that t is defined as greater than or equal to negative 3. And that's how you sketch a parametric curve and indicate its orientation. Could you use some extra help with math? Click the button to head over to calculusexpert.com. It's where I've collected and organized all of my best resources, including exclusive videos, notes, quizzes, and even formula sheets. It's the perfect resource whether you're struggling, or if you want to take your learning further, or even if you just want to save yourself some time studying. So check it out, because I know it'll help.